Okay, Bismillah ar-Rahman ar-Rahim. We start again. If you have my voice, just put confirmation in the box. Okay, thank you very much. We start a new chapter. Okay, it's very interesting chapter, not as complicated as encryption, but the basic of all of the most of the security solutions are encryption, and we had to review the encryption. We passed the encryption. Now we talk about the authentication. In this chapter, we discussed the authentication. Walaikum assalam. We discussed the authentication on the systems or operating system, and we discussed the authentication on the network. Okay, or in Arabic we call it al-musadaqa. Okay, if I'm not mistaken. Okay, al-musadaqa. Okay, authentication. So today, let me go to the board. We discussed authentication. Authentication always happens on the three categories, okay? Because on the network and on the system, you don't see the person and you cannot recognize the person. So the idea is that in somehow you know the person, or you can recognize that this is, for example, Rasha, or this is Zainab, I don't know, this is Haydar, or if they are not themselves, I can understand them because I cannot see my students on the network or through the networks or through the systems when you log in. So authentication can happen on what I am, okay, what I am, what I have, okay, and what I know. Authentication on what I am, we call them biometrics, okay. Biometrics like fingerprint, face, eye, and etc. Okay, what I have, these are the things that you carry with you. For example, bank card, metro card, tokens, through usually they send tokens through a smart phones. Okay, tokens that we send through the smartphones. Okay, contacts, yeah, contacts. For example, if you have somebody's number or you have MAC address, you can use it as interpret it as contact, but not exactly the contacts. Okay, so bank cards that you have, you use for example with ATM or Bank. Okay, you used your card with Bank and you withdraw money. or biometrics like finger and face. And something that I want to discuss here is what I know. What I know is like passwords, okay, and then patterns, and then for example card pins and something like that. Okay, so these are the three ways that we usually use for authentication. And also we say when we talk about authentication, it differs that whether we discuss authentication on operating system, login, or on the network. It's through the transfer. Authentication on operating system, login, or on the network through the transfer. First we will discuss the authentication through the systems, or the one which is login. Okay, first we want to talk about the login. The basic idea is that we can use something that you know. We can use something that you know, so it's what you know, which is the password. Okay, and we want to talk about the authentication on the system. The basic idea is that when you want to log into the system, it asks you for the user and it asks you for the password. Okay, user means that you claim somebody that you are. For example, for user you say Ali. This means that you say I am Ali. Okay, and then for the password, if you know the password, it means that you are Ali. If you don't know the password, it means that you are not Ali. So it should be some file or database in the system, for example one file or a database in the system that it says, for example, Ali with the password 123 or 123. Okay, and then it has the access to, for example, read. Okay, and then maybe we have, I don't know, Mariam with the password 456, and then it can read and write. Okay, and we have admin with the password for again 123, and it has full access. Okay, so there should be one file or database in operating system that when you claim to be Ali, you enter the password, the system goes to the file. Okay, the system goes to the file, find the Ali, and then compare the password that you entered. Compare the password that you entered with the password of Ali. So compare. And then the answer is yes or no. It means that you can log in or you cannot log in. Okay, this is the basic idea. So the problems with this, the whole story is that first, how you check the password, and the most important thing is that if you keep the password file on the system or you keep the file as plain text, okay, everybody can see anybody password. Okay, everybody can see anybody's password. It's in Arabic. Okay. يمكن لأي شخص رؤية كلمة المرور أي شخص. Everybody can see anybody password. So it's difficult to keep the file hidden because it's operating system. Everybody around the world use it. Okay, everybody has it. So it's impossible that for you to hide the password or password file. So غیر مخفیه. It's not good to keep it. We cannot keep the file secret. Okay, so it's impossible for you to keep the file secret. So the idea is that instead of saving the password or storing the password, something that you do is that you take the password. Okay, you take the password, you convert it to encrypted password, something like this. Okay, and then you store it. So in this way, when you store, instead of 1 2 3, you store this one. Instead of 1 2 3, you store, for example, this one. The hash of the password, nobody can see the password. Okay, now the question is, what is hash? Okay, the question is, what is hash? It's based, I will write it in the note, so for you to that can take a note and you have it. It's what is hash? What is hash function? It is a encryption algorithm with no key. The first characteristic of hash function is that that's an algorithm or encryption algorithm with no key. Second, it's 1 to 1, unique for each input. Another one is that, so it's impossible that, for example, you have A and B and the hash of A and B becomes, for example, for both Y. For A becomes Y and for B definitely it becomes Z. And also based on riyaziyat, spot riyaziyat. Okay, mathematically it proves that it's impossible that from the hash function or from the encrypted password or hashed password you can get the password. So it's not reversible. Okay, it's not reversible, and it is a 25 DES. Okay, it based on DES that we discussed and we taught in the number, hashes, letters, and hashtags. Okay, yeah, exactly. But that hash is this one. Okay, this hash is different. That hash is someone that was saying you talk about this hash, but this one is a function we use. Okay, so it's 25 DES with the small changes. DES we discussed in previous lesson in the last session we discussed how DES works. Okay, so it's almost a 25 times DES. It's very secure function, and then mathematically it has been proved that from the hash of something you cannot get the original one. So again, I fixed something I wrote on the board. I removed the Ali's password because I remove all of them. Okay, and now I should add Ali again. The name is Ali. Okay, and I want to have his password and access it, for example, read only. Okay, so when Ali says that my password is 123, here my password is 123, you create a hash of password which becomes this one, and then still not enough space. You put it here. So in operating systems like Windows 10 and like Linux, everybody can see the password file. Okay, everybody can see the password file, but when they open the file they can see the usernames, but they cannot see the passwords because the passwords had already been encrypted, because they are only encrypted passwords in the file. And we said that based on mathematics or اثبات ریاضیات, okay, mathematically it's impossible from this one you can get out the 123, the hash one. Okay, so this is what they do in the operating systems. Okay, let's go up to here on the slides, then we can go a little bit further. So we said that the basic idea is that we use something that you know, a secret that you know, to recognize you, to make sure that this is you. But the problem is how you store the password. We put it in the file or in a database on the system. How does the system check the password? We said that we encrypt the password, and when somebody claims to be Ali, we get the password, we encrypt it again, and then we check with the original password, and then we should do the analysis. So the idea, we take the password, for example kiwi fruit, we encrypt it and we put it in the password file. It's difficult from edge of the password to find the password itself. We already discussed this one. And then when somebody claims to be Ali, we ask for the password. For example, it says, okay, my name is Ali, and we say, what is the password? And say, for example, the password is 123. We cannot compare 123 to the file, so we calculate hash of 123. We calculate hash of 123. Whatever comes out, okay, we compare hash of 123 to hash of Ali's password. Okay, it's like this. We compare it, and then it's like that no password is stored on the disk. This is the whole idea. No password is stored on the disk. Operating system. When you enter operating system, we use the same function. Okay, for example, when you want to log into Windows 10, okay, it asks for username. You give the username and it asks you for the password. But Windows 10 does not have your password, Ali. It does not. It didn't store your password. Nobody has your password. Even websites and Windows and Android, and nobody, even banks, they do not store your password. They only store hash of your passwords, and when you enter your password, they check the hash of the claim password with the hash of the original password. If it matches, they will let you in. If it doesn't match, they don't let you in. So it's like that. Nobody knows your passwords. Okay, and there is no place on the earth. Yes, exactly. There is no place on the earth that your password is stored. For example, if I ask you, what about your Facebook password? Okay, or what about your Gmail password? Who has it, or who can read it? Or what about, for example, your, I don't know, WhatsApp password, or whatever it is? Or what about your bank card password, where it is stored? What is the answer? Nowhere. The answer is nowhere. Yeah, only in hash. Okay, so if I ask you, where does your password stored, you can say la makan. Okay, you can say no makan, nowhere. Your password is only there are hashes, and from hashes you cannot get the password out. Okay, so this is it. It's the way that we store the password. The hash function is 25 rounds of DES variant. We already discussed this one. Password file is publicly readable. Everybody can see the password file, but they cannot access the password. But there is one problem. There is one problem that you can just use dictionary attack to calculate every word, or to calculate hash of every word in the dictionary to get out the password, or to compare the password. Okay, that's the problem that then we want to introduce one concept that we call it salt. Again, I go to the board. You see, consider that this is Ali, and the password is 123, and the hash of the password is this one. Okay, and this is Mariam, and the password is 123, and again the hash of the password of Mariam is this one, and this is admin. It's his password is 123, and the hash of the password is this one. You see, for 123 it's always the same hash function because it's 1 to 1. I already wrote this one in the note. So what you can do is that you can create a dictionary. Okay, in Arabic we say قاموس. Okay, you can create a dictionary for all the possible words. Okay, for all the possible passwords. Okay, you can create a dictionary for all the possible words. Okay, but it can be smaller, because for example, if it's in Persian, we know what passwords usually Iranian use. okay, what names they use. If it's in Arabic, you know most of the names that for example Arab people use as their name or as their password. For example, if it's in Europe, usually people use their pet names, okay, like their cats and their dogs as their passwords. Okay, so you use social engineering and you use statistics to make it smaller. Okay, for example, if this is the all possible words for passwords, it's for example this one. Okay, if you know the culture, if you know the culture, if you know the habit, if you know the names, okay, and if you have statistics, احصائيات, if I'm not mistaken. Okay, if you have the statistics, this dictionary becomes smaller. For example, it becomes like this one. Okay, smaller. It's not in the dictionary, Ali. The dictionary that we talk about it is not the dictionary of the words. Okay, if the dictionary of common passwords. But if the password is not in that, you will fail. Okay. Okay, Marva, the attacker uses apply the hash function to all the words in the dictionary and compare them with the that saved. Yes, exactly, Marva. Now we're trying to explain this one. Yes, exactly. Maybe later you write it in Arabic for your friends. Thank you very much. Okay, so it's for example 1 billion words or whatever it is with statistics and social engineering. Here I write social engineering and statistics. You make it smaller and then you use your computer to hash the whole dictionary. Okay. Ali, listen, you see the something that I meant by قاموس or dictionary is not the names. It can be like, for example, Ali 1 2 3, okay, or it can be A 1 2 3 4 5 6, or it can be M, for example 1 2 3. Okay, it's something like that. It comes from statistics, احصائیات, or it comes from social engineering. It's not the normal dictionary, it's the hackers dictionary, the common names or common passwords that usually people use. Okay, you got it? So, or for example, hello 111, okay, or I don't know, for example, or me 1 2 3 4 5, okay, something like that. So this is the dictionary. You calculate the hash for all of them because it's computationally it's very difficult. Maybe it takes, for example, 1 day for you, or maybe it takes 1 week for you on your computer, or it takes 1 month for you. Is not important. Now after you calculate this one, you have a new dictionary. Okay, after the calculation you have a new dictionary with 100,000 words, okay, which are all hashed. Okay, all hashed. Now it's easy that with one simple if, it's easy with one simple if you can compare the hash of the passwords of the people with the hash in the dictionary. If it's same, you can get, for example, 1 2 3. Okay, if it's same, you can get 1 2 3. It's easy. Okay, this is it. If you got it, now I want to go to the next step. Make sure that you understood the concept. Okay. Rasha, thank you very much. There are some people, the students, they are always active in the class and listen. Thank you very much. Thank you, Marva, you as well. Okay, so this is it. To solve this problem, okay, that's the problem with hash, because the hash is 1 to 1, okay, because the hash is 1 to 1, and when your password is 1 to 3, it's always same hash. Okay, to solve this problem, they introduced a new concept. They have introduced a new concept. They call it salt. Salt is in Persian namak. In Arabic, what do you call salt? Mel. Okay, mel. We call it the same thing, mel. Okay. In salt, something that we do, we will use some bits. It's not important again how many. The more are the bits, the more complicated is the technique. We use some bits, okay, or some characters. We use exactly namak. Thank you, Hassan. Yes, we use some bits or some characters which are not, which they are random in Arabic. Ashwa'i, okay, it's ashwa'i and not secret, not hidden. Okay, not secret, not hidden. So when you ask operating system, for example, Windows 10 or I don't know, Android or Linux, okay, your operating system, okay, when you say I'm Ali, it says okay. And when you say okay, my password is 123, it doesn't calculate the hash for 123. Okay, it also generates one random characters or random bits. For example, it generates GH, okay, as random. Okay, it also generates GH. Then it creates a hash based on this one. It says okay, for Ali I hash 123 GH. Okay, it creates one random, yes, تولید عشوایی, okay, one random GH, and it hashes the 123 GH, and then it stores something like this. So the output is like Ali and then GH, and then the hash can be like this. Okay, the password generates random. Yeah, exactly, it generates random. So the password, compare this one to this one. You see, if you look at this one, the password of Ali is 123. Okay, yes, system generates random. You see, for this one, the password of Ali is 123, and the hash of 123 is this one. But here also the password of Ali is 123, but the hash is not same. Yes, creates random for each person. Okay, again, consider we talk about Maryam. Okay, for example, we talk about Maryam. You see, again, when Maryam says okay, my name is Maryam, okay, when Maryam says my name is Maryam, okay, and ask for the password, Maryam says my password is 123, okay, same password. No, never by itself, Marve. We also use the salt, okay? System creates another random only for Maryam, like EW, okay? It creates something exactly for Maryam, like EW. So it hashes 1 2 3 EW, okay, and then it stores this one for Maryam. So you see, although not that hash Ali, that's different thing. It's just a function which includes 25 DES fistel that we taught in the last session, okay, that encrypts the passwords. We use this function. It's like a function, like f, okay, it's like a function. You give something like password and you receive something else, okay, which is encrypted password, and inside is DES, okay, inside is similar to DES, okay. So you see, the password of Ali is 1 2 3, and the password of Maryam is also 1 2 3, but the hash of the stored password for the Ali and the stored password for Maryam is not same, okay. So this is it. So what is the application of the salt? You see, if you remember, I told you that attacker, okay, or hacker will go here. I write hacker, okay, or attacker. The hash is same, Hussein, but the salt is different. That's why the result becomes different. Okay, so you see, for the attackers, if it creates a file for the password, which is, for example, 1 to 3, okay, it cannot use it against all of the databases, okay. So it's impossible to use this one, so we threw it away because none of the passwords are similar to the passwords in the dictionary. But some and then it should calculate the hash. Maybe it takes 1 day, maybe it takes 1 week, 1 the salt, because for us there is no problem changing the salt. Okay, if we do not change the salt, attacker can use the same dictionary again and again. If we change it, because it has to calculate a new dictionary, the attacker should calculate everything again. Okay, because for us it's easy. So you change the salt GH to, for example, it's not hidden. You change it GH to ML. Okay, no problem with the login, because in login again operating system use ML. Okay, no problem with Ali. Every time Ali changes his password, you change the salt. One is ML. Okay, again you change the password is FG, again you change it is ER, again is VT. Okay, whatever it is. For checking the password is easy, but for attacker, when you change the salt, the attacker should calculate the dictionary again. Okay, for the attacker, each time you change the salt has to calculate the dictionary again, and it makes the attacker suffer, or it makes the attack slower. Okay, let's go back to the slides. So dictionary attack, is it possible to predict? Mustafa, something that you can do is that you calculate all the possible salts and add them to the dictionary. But again, when for example you have 100,000 words dictionary, again it becomes something like this. Okay, it becomes again something like this. You have to try it, but you can calculate all the possible salts and then create a bigger dictionary. Okay, but it's possible. System generates the salt. Yeah, each time you add one record to the password or you change the password, system randomly generates the salt. Okay, so on the passwords, we said that we can use dictionary attack. Same dictionary can be used for all of the password. So for all of the operating systems, because we want to do the same thing. We want to calculate everything. It's riyaziyat. Okay, we say for example you have a dictionary with 1,000 entries. Okay, you have a dictionary with 1,000 entries, and assume فرض کنید, assume that you can check 10 guesses per second. Okay, it takes you for checking everything in the system, it takes you 28 hours. This is the worst case, or 14 hours average. So I will write here 14 hours or 14 saat. Okay. Now, if we use the random characters and numbers, for example, upper and lower case, and we use digits, and we use specific symbols, and so on and so forth. So exhaustive search, it takes 1000. Yes, you can compare. So you convert 14 saat to 1000 sena. Okay, it's the difference. So if you use the salt, or if you use random characters, if you use a combination the network. So here is it's the difference. So if you use the salt, or if we use the random characters and numbers, for example, upper and lower case, and we use digits, and we use specific symbols, and so on and so forth. So exhaustive search, it takes 1000. Yes, you can compare. So you convert 14 saat to 1000 sena. Okay. It's the difference. So if you use the salt, or if you use random much. Oh, no holiday in Iraq. Okay, okay. But in Iran, we have 2 weeks holiday. Okay. Okay, thank you very much. We can start networks. Okay, I will write it down. If you have any question, you can ask. If no, the class finished. I have nothing to say. Okay, so it's up to authentication.